Hello everyone, this is Jan. Hope you're doing well. So having looked at the topic homeostasis in living organisms and finishing it, I'm taking us through a review of some of the questions that are normally asked or some of the questions that fall under this topic. Question 1, it is showing the changes that occur in concentrations of insulin and glucose in the bloodstream of a person who has lasted over a night and then swallowed 75 grams of glucose. Concentrations on the vertical scale, we have concentration of substance in blood. And on the horizontal scale, we have time taken. Now, when you look on the calibration on the horizontal scale, we are looking at a point between 45 and 15 minutes where we are having 75 grams of glucose being given to this individual. When this guy is given glucose, we are looking at the concentrations of glucose in the bloodstream also increasing, and we are also looking at the concentrations of insulin in blood also increasing. Now, why are we looking at this taking place? We are seeing the increase in glucose, increasing the concentration of insulin as well. Why? What is the relevance of this hormone increasing? We looked at glucose concentration levels, maintenance of the norm glucose concentration at 90/100 milligrams in the body. Now, when glucose concentration is high, you expect the secretion of insulin by the beta cells of the islets of the Langerhans that would bring about conversion of glucose to glycogen, increase cellular respiration, bring about conversion of glucose into fats that could be stored. All this, it brings about lowering the concentration of glucose levels. Now, our question 1, having looked at the significance and the relevance or the relationship, we have question 1, which says compare the levels of glucose and insulin after swallowing glucose. Now, when a question comes and it is saying compare, we are making a comparison where in our mind, we need to have two things, similarities and differences. That is comparison. When we look at the similarities, we are looking at the levels of glucose and insulin. Both concentrations have peaks. A peak is attained when this guy increases and reaches a point and then it falls immediately. That is a peak. But if it does not fall and it first attains a constant, then we call it maximum. So we have to differentiate between a peak and maximum. Both concentrations rise and fall. Or you can say in both glucose and insulin, their concentrations rise and fall. When glucose was given to this person, there was an increase in glucose concentration in blood. And then as well, there was an increase in insulin concentration in blood. But a point reaches when these guys attain a peak and later they fall. What are the differences between these two guys, glucose levels and insulin levels? We are looking at glucose levels. Peak concentration is attained earlier than the concentrations or than the peak concentration of insulin. You are looking at the peak concentration of glucose attained at around 90 minutes, whereas the other one is attained around 100 minutes. Glucose levels, they have a higher peak concentration, whereas insulin has a lower peak concentration. And all the time, throughout, we have the concentrations of glucose higher than the concentrations of insulin. Explain the changes in the concentration of glucose and insulin. Why do you think the concentration of glucose is always higher than the concentration of insulin? And why do you think when the concentration of glucose increases, then the concentration of insulin also increases? So we are looking at, when they say explain, I expect you to first give a description. You're expected to give a description. Then after giving a description, then you give the explanation. Now, with the description, what are the marking points? You give the range on the horizontal scale, and then you give the description on the vertical scale. Look, between 30 minutes and 90 minutes, we are having glucose concentration increasing gradually. Why is it increasing gradually? It is being absorbed from the gut. But between 90 minutes and 150 minutes, we are having glucose concentrations decreasing gradually. Why? There is being converted, or glucose is getting converted to glycogen or fat, or we have increased oxidation by the cells, or we have uptake by the cells in presence of the hormone insulin. Now, once the glucose concentration has increased in blood, then we cannot let it go high beyond than the norm. Because you are looking normally, when this guy was not given a meal or was not being injected with glucose, then it was constant. But look, when glucose was injected, its concentration had to increase. So once it was injected, then it will be absorbed from the gut. It will later decrease because we cannot let that glucose accumulate in the body and remains in high concentrations. So what is happening? Glucose is converted to glycogen. There is increased oxidation. So what is happening? All this happens due to insulin hormone. Now, when you look at the concentrations of insulin, we are having between 45 minutes and 105 minutes. The concentration of insulin increases rapidly because there is glucose concentration exceeding the set point, which will bring about stimulation of the beta cells in the pancreas to secrete more insulin. So insulin is being secreted to lower the glucose levels back to norm, that is between 105 and 150 minutes. Now, when the glucose levels start reducing and they are coming back to the norm, then the concentration of insulin also decreases slowly because these guys are decreasing towards the norm. Question 3, explain how the concentration of insulin would change if the person engaged in an exercise. What would happen if this guy engages or he performs an exercise? When someone is exercising, then you expect to have increased cellular respiration. You expect to have increased cellular respiration. Now, look, if you have increased cellular respiration, then because when you're exercising, you need ATP. Now, you are using up glucose. It is being metabolized to provide energy. So what is going to happen? We are going to see the concentrations of insulin reducing because its secretion from the pancreas would be inhibited. Why? Because for it would bring about lowering the glucose levels, yet we need to increase the concentration of glucose in blood that would be used for cellular respiration to generate ATP. We have another question. Figure 2 shows the changes in the amount of liver glycogen and glucose concentration in blood of a person during a prolonged exercise. We are looking at the vertical scale, the mass of liver glycogen in grams, and on the right-hand side, we have the concentration of glucose in blood. Then, it should be glucagon, not glucose. Concentrations of glucagon in blood, not glucose. Figure 1, question 1. Describe the effect of prolonged exercise on the amount of glycogen and the concentration of glucagon in blood. What is the effect? What effect does prolonged exercise bring on the amount of glycogen and the concentration of glucagon in blood? We are having prolonged exercise lowering the amount of glycogen to a minimum, but then it increases the level of glucagon up to a peak, and thereafter the level reduced. Now, depending on the marks that are provided on this question, and they are saying describe the effect of prolonged exercise. This is what should be answered. But if they say describe the changes in the amount of glycogen and concentration over the prolonged exercise, then you would come giving the descriptions from 0 or between 0 to 5 minutes. This was taking place. The concentration of glycogen is almost constant or reducing gradually. Between 5 to 10, the concentration of glycogen decreases rapidly, and so on and so on. Now they are asking us, explain the trend in the mass of glycogen and the concentration of glucagon in blood. Now this is what I was talking about, where it comes in. You are having between 0 minutes. Now they're asking you to explain the trend. Now the trend, you cannot base it on the effect of prolonged exercise. If they say describe the changes that are taking place, describe the trend in the mass or in the amount and the concentration of glucagon in blood, then you are required to give a description where you give a range from the horizontal axis, and then you give the description from the vertical axis. So we begin our description. Between 0 minutes and 5 minutes, the mass of glycogen decreases slowly. And this is because the concentration of glucose in blood is still high. Remember, someone is starting now. Someone is starting the exercise. So that means the glucose stores are still very high in the body. Once they are used up, that is when the body resorts or the body brings about secretion of the hormone that would bring about conversion of glycogen back to glucose. Now, what are we seeing? Between 5 minutes and 10 minutes, we are looking at the mass of glycogen decreasing rapidly. Why? Because the glucose levels in blood have reduced so much. Therefore, glycogen is getting converted into glucose. Why is it getting converted to glucose? To provide the energy for the exercise. Then between 10 minutes and 20 minutes, we are having mass of glycogen reducing slowly because glycogen stores in the liver have been exhausted or depleted. The concentration of glucagon between 0 minutes and 6 minutes, this guy is increasing very slowly because the need for its conversion into, or because the need for glycogen conversion to glucose is still low. This is the hormone that is secreted by the alpha cells of the islets of Langerhans. It brings about conversion of the stored glycogen back to glucose, bring about glucose production from non-carbohydrate sources, and so on. Increases cellular, or it will bring about decreased cellular respiration, but still, all this is taking place to provide the glucose that will be used for respiration. Now, between 6 minutes and 20 minutes, we are seeing the level of glucagon increasing rapidly, which will promote conversion of glycogen into glucose. And then between 20 minutes and 30 minutes, the level of glucagon decreases gradually because glycogen stores are depleted. Now, what does it mean? We are seeing as the concentration of glycogen decreasing, then the concentration of glucagon is increasing. This is because glucagon hormone is bringing about conversion of the stored glycogen back to glucose. Suggest how continuous supply of glucose is ensured after the 25th minute. Now, when we are looking at the control or at the control of glucose levels, homeostasis of the normal blood sugars, we saw the effect of other hormones like adrenaline and cortisol hormone. Now, particularly after the 25th minute, we are looking at the adrenal glands secreting cortical hormone that will promote the conversion of amino acids and glycogen into glucose by the liver cells. So glucose is getting converted from other non-carbohydrate sources. More glucose, more glycogen, maybe that is still present, converted by cortical hormone, and then we have the amino acids also getting converted into glucose by the liver cells. That is the first question. You can try out this question, which shows the average blood glucose levels in the 3 major vessels of the liver of an individual who had meals at 7:00 a.m. and then 1:00 p.m. Use the information to answer the questions that follow. We are having blood glucose levels on the vertical scale. Then we are having time of the day. And then we have the 3 vessels around the liver. So you are required to compare the levels of glucose in the hepatic artery and the hepatic vein. You have to talk about the differences and similarities, 4 marks. You are required to talk about the hepatic artery and the hepatic portal vein. Also, you give the differences and similarities. Then you are required to explain the difference in the levels of glucose in the hepatic artery and the hepatic vein. Of course, you will be basing on the differences you would be explaining the differences in the levels of glucose in the two veins, in the two blood vessels. So you look at the differences and then you explain why do we have a difference in the hepatic artery and the hepatic vein in the levels of glucose. Then you have figure 2, which shows the blood glucose levels in a normal and a diabetic individual after both individuals were given a sugar solution at 7 a.m. and study the information and answer the questions that follow. You look at the concentration of glucose on the vertical scale, and then you have time after glucose ingestion. That is, you are looking at the diabetic individual and the normal individual, and you're required to compare the levels of blood glucose between the two individuals. Then you are required to give an explanation for the observed pattern of levels of blood glucose in the two individuals. Maybe to give a hint on this question, comparison, you talk about the differences and similarities. When you look at the similarities, both concentrations rise, both concentrations fall after the rise, and then both concentrations, they attain the peaks. And generally, there is a gradual decrease from 12:00 to 1:30 p.m. When you look at the differences, you have an increase, it is steeper for the diabetic individual, and then glucose level in a diabetic individual is higher throughout and lower for a normal person. We are seeing the peak concentration being attained very fast earlier in a normal individual than for a diabetic. And then after 10 p.m., diabetic peak continues to drop, whereas the normal person's blood level remains constant, all levels off. An explanation for the observed pattern, we are having increase in glucose concentration, which is due to absorption of glucose after digestion. The peak is higher in a diabetic individual because of lack of regulation. Either the pancreas is malfunctioning, there is no secretion of insulin that would bring about conversion of the glucose that has increased in levels to glycogen, and then it stays a bit lower, as in a normal individual. Now, in a normal individual, it is not allowed to go beyond the normal levels. It increases slightly and later falls back to normal. So the concentration of glucose levels off after regulation, and this is due to homeostatic control of glucose or release of insulin, that is in the normal individual. And also in the diabetic individual, but the concentration of glucose falls because of lack of regulation and due to excretion of glucose or removal of glucose in urine. So what is happening? Now, remember, in these two individuals, one, there is no homeostatic control of glucose. That is the diabetic individual. So the glucose that was increased or the glucose that increased later falls in this guy because it is excreted in urine. That is a condition known as glycosuria. We have glucose moving out of this individual through excretion in urine. But for a normal individual, there is homeostatic control or there is regulation of glucose by insulin. Now, when the level comes back to norm, what do we expect to take place? We expect this guy to reduce the levels. So there is no continuous conversion of glucose. That is why it falls off or it levels off back to norm. But this one continues to fall because all the glucose is moving in urine other than being controlled by hormones. What is the significance of the physiological process illustrated in figures 1 and 2? What physiological process is taking place? What is the significance? We are looking at glucose being a respiratory substrate for the cells, such as the brain cells or the main metabolite for cells. And if there is lack of glucose, it results into hypoglycemia or fainting or ketosis because the body lacks energy. We are looking at glucose concentration affecting the osmotic relations of cells or regulation of water and salts. So what physiological process is taking place? It is homeostasis, regulation or maintenance of the glucose levels around the norm. So if this concentration increases highly, then we are going to find out that it is affecting the osmotic relations of cells or regulation of water and salts. If there is excess glucose, it would result into breakdown of body cells or muscle tissues or brain cells or loss of weight. You can also try out question 3. Which says, in an experiment, a person who does not have diabetes ate 2 slices of white bread, and the changes in her blood glucose concentration was recorded over the next 120 minutes, and the experiment was repeated first with 2 slices of bread and then with 2 slices of wholemeal bread. And this figure shows the results of the 3 experiments. You are looking at them. So look at the increase in blood glucose concentrations. Once with white bread, that is the arrow on top, then brown bread, the one in the middle, and the one down for wholemeal bread. Then figure 2 shows the concentrations of glucose in blood of two people. Person A is non-diabetic and person B has diabetes. Each person ate 75 grams. That one is almost resembling the one that we have finished talking about. And then which type of bread would be more suitable for a person with diabetes? You give 2 reasons for your answer. Then you explain as fully as you can the reasons for the changes in blood glucose concentration when the person ate brown bread. From figure 2, you are explaining the observed changes in the glucose concentration in both persons after the meal. And then you explain the 2 dangers of having high concentrations of glucose in blood. What effect would high concentrations of glucose bring about? How dangerous would it be in the body? Then question E, the pancreatic cell transplantation is a new treatment for diabetes. You have insulin-making cells are taken from up to 3 dead donors. Then these guys are kept alive before being injected into the diabetic person in a small operation. So these cells begin to make insulin soon. And in one recent study, 58 of the recipients of pancreatic cell transplants no longer needed insulin injections. Give advantages and disadvantages of the new treatment for diabetes compared with using injections of insulin. So kindly go through that question. You have another good question down, which shows an experiment. In an experimental, the animal, the hepatic artery was ligatured, and then the rate of blood flow through the hepatic vein measured. The glucose concentrations in the hepatic portal vein and the hepatic vein were measured at 15 minutes intervals, and presently insulin was injected and subsequently adrenaline. So you have the table and required to plot a graph that shows the changes in the intake or output of sugar by the liver. You look at the graph. It looks like this. So plot this graph. When you are plotting a graph, you expect to have a title. You expect to have a scale. You are expected to label the axes very well. And then you plot the measurements that have been given to you. So when you plot your graph, make sure it should resemble this. Okay. You are, after drawing the graph, move on and compare the blood glucose concentration in both veins before the hormones were administered and after, that is, before hormones were administered, then when insulin was administered, and then when adrenaline was administered. In each of the 3, make sure you give the similarities and the differences. When you stop the video, you can pause and you read through these similarities and differences depending on, and you see the differences that they have with yours. Continue and you explain the blood glucose concentration in both veins. First, before the hormones were administered, why do you have the observed similarities and the differences that you've given above? When insulin was administered, you also explain the observation that you have. Also, when adrenaline was administered, you also give the explanation for the observed differences. Then you are also required to calculate the quantity of urea which would be excreted by the kidney in 1 hour. If the rate of flow of blood through the renal artery was found to be 1,200 centimeters cubed per millimeter, the urea concentration in the renal artery was 32 milligrams per 100 centimeters cubed, and in the renal vein, it was found to be 24 milligrams per 100 centimeters cubed. So blood flow from the kidney is 1,200. Then the urea concentration is 32 grams per 100 centimeters cubed in the artery and 24 milligrams per 100 centimeters cubed in the vein. So that means if blood flow is 1,200 per minute, then in an hour, which has 60 minutes, you get the blood flow. To get the volume of blood, you get the blood flow, which is 1,200 centimeters cubed. That is the rate. And you get the volume in 1 minute, which is 1,200 centimeters cubed times 60, you get 7,200 centimeters cubed. That is 72,000 centimeters cubed. That is the volume of blood through the kidney in 1 hour. Urea excreted by the kidney per 100 centimeters cubed of blood is 32 minus 24. The one in the artery and the one in the vein. That means the one that is excreted is the one that doesn't go to the vein. That is 8. So to get the urea excreted by the kidney in 7,200 centimeters cubed, you get 8 times 7,200 out of 100 centimeters cubed. You end up with 5,760 milligrams of urea. And so on, and so on, and so on. I'm going to record another video which talks about some of the temperature regulation questions like this one. It will be beginning from this that shows the basal metabolic rate of various mammals. Thank you for watching. Subscribe to our YouTube channel and follow for more.